Why are the two sides of the moon so different? Will you accept a suggestion for your leisure time? Sit by the sea or look out from the balcony of a great mountain range. Take 5 minutes to look at the moon and let your mind go back to the unconscious times when the spots on the moon represented a world of ever-changing figures. Try to discover new ones, then come back to yourself and, rationalizing your knowledge, ask yourself a question you may have never really thought about. Why are the lunar seas all concentrated in the hemisphere facing Earth? The problem, as you will see, is far from trivial, and the solution is far less intuitive than you might think. It seems that the oldest known depiction of our satellite, over 5,000 years old, was found at Knoweth, a mysterious Neolithic site in County Meath, Ireland, engraved on a stone showing dark marks resembling lunar spots. Whether it is true or not, often these attributions are only illusory and obviously unprovable. It is impossible to doubt that since the earliest prehistory, the human species has looked up to the sky to question the meaning of that silver disk dotted with spots. There is no doubt that even in historical times, the moon played a significant role in every culture, all the more so with that strange configuration of light and dark areas in which everyone could read the roots of their own culture. Thus, in the Western tradition, the figure of Cain fleeing, that of the two lovers kissing, the man with the wood on his shoulder, the hare or the buffalo among the Indians and some Asians, the toad among the Aborigines, the seals among the Eskimos, or the backlit trees among the Polynesians are explained. Of course, all this would have seemed perfectly natural even to the most enlightened minds of those centuries, when the moon, once a two-dimensional mirror reflecting human fears, became a three-dimensional celestial body worthy of scientific speculation. A world that, due to a cruel game of gravitational resonance, always showed the same face to the inhabitants of the Earth, but which on the dark side surely had to hide countless other oceans and possibilities for inventing new stories with other animals and figures. And who could have ever have refuted this certainty? When would it have been possible to reach the moon and look beyond this ancient landscape that has been with us for millions of years? An epochal turning point. But the moment comes for all things, and what had been considered impossible for centuries became reality in just a few years. On October 7, 1959, the Soviet probe Lunar 3 turned the corner and sent back to Earth a handful of faded photographs of the hidden hemisphere. So ugly and noisy that looking at them today, it's not easy to suppress a sense of wonder at the realization that they were taken only 50, not 1,000 years ago, but still effective in showing that there was little or nothing on the far side of the moon. A uniform expanse of craters, large and small, a surface scarred by time but almost entirely devoid of the contrast of seas and continents that had captured the imagination of mankind for so many centuries on the near side. It seems that most of what was worth seeing on the moon was concentrated on the face facing Earth. Of course, it was not exactly like that. It was just a new scientific problem. Puzzlement. The most surprised by this revelation were indeed the experts in the field, who, although still in this controversy about the volcanic or impact genesis of the craters, had managed in previous years to form a rather reasonable picture of the turbulent history of the lunar landscape. What popular culture defined as spots on the moon were for official science nothing more than large basins filled with impressive lava flows of darker material, surrounded by the higher regions, the so-called highlands, whose tortuous terrain clearly told of a past marked by the violent and destructive action of cosmic projectiles of every dimension. Given this explanation, assuming, as is obvious, that the meteorite bombardment affected the lunar globe as a whole, nothing could therefore presuppose that the hidden hemisphere could have characteristics that were too different. A certainty supported by the fact that the liberation zones made it possible to see, especially on the eastern edge of the visible face, some dark formations, the mare marginis, that were imagined as extensions of large lava basins, also present on the hidden hemisphere. The reality shown by the photos of Lunar 3 and then by the subsequent probes appeared instead completely different, and selenologists were forced to interpret the existence of a visible hemisphere, where the dark lava expanses occupy 30% of the total observable surface, as opposed to the hidden one, where the seas cover only 2%. How could such diversity be justified? The reaction. The first explanations invoked a marked asymmetry in the flow of cosmic projectiles hitting the moon. The idea was that the presence of oceans on the side facing the Earth could be attributed to a greater number of high-energy impacts than those that affected the hidden side. But how could such a trend be explained? Some have suggested that the presence of Earth's gravitational field could somehow focus a greater number of space projectiles on the visible side of the moon. However, computer simulations have not shown such striking differences in cratering rates. Moreover, and this is the weak point of this and many other reconstructions, no one knows what the actual orientation of the moon was at the time of the meteorite bombardment. Another theory proposed that these projectiles were nothing more than primitive small satellites of the Earth that, before ending their course on our planet or on the moon, traveled in orbits closer to the lunar one. In support of this scenario, it has also been pointed out that most of the lunar seas extend over an area between 30 degrees south and 50 degrees north, a distribution compatible with the arrival of projectiles that traveled in orbits roughly on the same plane as the lunar one. The problem, however, is that the hidden side is by no means devoid of traces of impacts as energetic as those that characterize the visible side, a sign that the entire surface of the moon has been hit by projectiles of all sizes and energies. To answer such an objection, it has been suggested that the lunar dichotomy could be explained by the different results obtained depending on whether the impact was from internal or external projectiles. In other words, if the lunar surface was struck by small primitive satellites, the energy involved was certainly sufficient to bring some of the materials involved to the melting point, and this explains the presence of lava materials, but insufficient to vaporize a substantial portion of them. However, the case is different for projectiles coming from space, which are much more energetic due to their higher velocity, and therefore capable of vaporizing a large amount of material, leaving minimal traces of molten material. This explains the scarcity of lava plains and the massive presence of rocky terrain at a time, the 1970s, when it was still believed that the moon had been captured by our planet along with other minor satellites. Whereas today we know, or we think we know, that our satellite was formed by the orbital coalescence of material torn from the surface layers of the Earth by a giant cosmic impact. A new surprise. But it was not only the impact mechanism that was questioned. The famous American astronomer Gerard Kuiper also invoked an asymmetric distribution of intense volcanic activity, but this idea did not gain much traction, in part because it could not explain how such a marked difference in geological activity could exist between the two hemispheres. The possible gravitational effect of our planet was also not forgotten. For example, according to the Czech astronomer Zdeněk Koppel, in the distant past, the moon was so close to the Earth that its hemisphere closest to us, but not the other, was even within the Roche boundary of our planet, in a situation where it is logical to expect that the differentiated tidal action could considerably damage the closer hemisphere, favoring the eruption of lava. These were certainly ingenious explanations, but they quickly showed their limitations, especially when a more detailed analysis of the cratering and elevation measurements of the hidden side suddenly overturned the assumption that large impact basins were found only on the Earth-facing side, a cornerstone of those who hypothesized and still hypothesize an asymmetric bombardment. Even on the hidden side, impact craters of considerable size have been found. In fact, the largest lunar impact basin, and one of the largest on the surface of any body in the solar system, is located in this hemisphere. It is the Aitken Basin near the South Pole, a crater with a diameter of 2,500 kilometers and a depth of over 12 kilometers. In the absence of a clear differentiation of the surface, all questions at this point could be reduced to just one. Why, given the uniform impact crater on both hemispheres, was there a conspicuous lava flow only on the side facing us? Towards a common solution? The explanation proposed today to answer this question is based on the difference in the thickness of the lunar crust. This thickness is estimated to be about 70 kilometers on average. For comparison, the Earth's crust is only about 10 kilometers thick. But observations have shown that the crust is about 60 kilometers thick on the visible side, while it is more than 80 kilometers thick on the hidden side. And with that, a conclusion seemed to have been reached. Given a homogeneous bombardment over the entire lunar surface, lava seas only formed where the crust was thin enough to be infiltrated by impact-driven volcanic magma. Problem solved? Not even close. It gets more complicated. Apart from the fact that it remains to be explained why the crust is thinner exactly in the hemisphere facing the Earth, someone has immediately objected that there are also regions on the hidden side characterized by a very thin crust, but nevertheless no magma outflow has occurred there, at least not as massive as on the visible side. So here we are with the resonant impact theory, showing how everything is still up for debate. This theory suggests that the triggering cause of the magma eruption must be traced back to a violent impact on the hidden side. The event would then have generated shock waves so intense that they penetrated the moon's core and activated a hotspot in the opposite hemisphere, just as the impact that created the Caloris Basin on Mercury caused a surface disturbance of the terrain at the antipodes. And the idea may not be so far-fetched if we consider that the large Aitken Basin lies exactly at the antipodes of the most extensive lava plains in the visible hemisphere. A preliminary conclusion. Can we therefore declare our hunt for the origin of the asymmetric arrangement of the lunar seas over? At the time of our disposal requires us to do so, but we are aware that there are still many unanswered questions scattered along the path we have traveled. Not to mention all the questions we have tried to avoid more or less elegantly, deliberately avoiding even a hint, such as the non-secondary role of the mascons, the anomalous mass concentrations buried beneath the lithosphere. In other words, we're still at sea, and the leopards of the moon, as the great poet Samuel B. Yeats called the great dark spots, are far from being explained.